right, so this next video is all about polar coordinates. And basically the polar coordinate system is a two-dimensional system, which is where we use to determine a point given an angle and a radius. All right, and sometimes we're given the point and we want to figure out, okay, here's where the point is. We want to know what's that angle and what's the radius at that spot. And so both things, we have to be able to go from each direction. Okay, so let's start with to go from rectangular coordinates to the polar coordinates. And by the way, that picture that you see there that kind of looks like a butterfly is a polar coordinate graph. Isn't that interesting? If you had graphing calculators, those are the ones that kind of make the really neat, I'll call them bubbly kind of graphs. They really are kind of unique. All right, so let's talk about it. Remember that a polar coordinate, as I just said, includes a radius and an angle. And when we're talking about the fact that we have the point 2, 2, here's the point 2, 2, we want to know what's the length of this, which is r, and we want to know the measure of that angle. That's what we're doing. Okay, so we drop that vertical line down and we can see, okay, I've got a triangle here. I need to figure out that stuff. So our first step in going from rectangular to polar is to find the radius. Well, see, I know what this is. That's 2, and I know this is 2. So to find radius, how would I do that? Good, Pythagorean Theorem. So I'm going to go 2 squared plus 2 squared equals r squared. So I have 4 plus 4 equals r squared. 8 equals r squared. So therefore r is the square root of 8, or 2 square root 2. Sorry, that skipped there. So that gives me my radius. So I'm already halfway done. 2 root 2 is the radius. Now, to determine the angle, so the first step, I'm going to write that down, find the radius, okay? Step 2 is to find theta. To determine theta, I'm going to write this down, find theta. All right, to determine theta, here's what you're going to do, okay? You're going to take your coordinate, you're going to divide your coordinate by the radius. So let me show you. Here is our coordinate. Our coordinate, if you recall, is 2, 2. So what we're going to do now is we're going to divide by our radius. Okay, and we're going to simplify it. And so when I simplify, I notice, oh, those 2's divide out. That gives me 1 over root 2, comma, oh, that's 1 over root 2. And then we're going to match it to our reference chart or reference angles that we do know. What angle do you know has a cosine that's equal to 1 over root 2? Or a sine that's equal to 1 over root 2? And of course, that just is the answer, pi over 4. Now we notice that they're both positive, so that tells me it is in the first quadrant, and we're good to go. It's the pi over 4 angle that's in the first quadrant. Let's try another one. All right, root 3 over 2, comma 1/2. So my first job is to recognize, okay, I've got root 3 over 2. I don't really know what that looks like, but I'm going to do it like this. And 1/2, and I'm going to put that point. Great. So I want to first figure out what r is. Again, my y value is 1/2. My x is root 3 over 2. So I'm going to go root 3 over 2 squared plus 1/2 squared. So square root of 3 squared is 3. 2 squared is 4. 1 squared is 1. 2 squared is 4. Oh, easy enough. That means that my radius is 1. So I've already set that up. I've got the first part of my polar coordinate. All right, part number 2 then is I'm going to take my coordinate, root 3 over 2, comma 1/2, and I'm going to divide them both by 1. And of course, when you divide by 1, it doesn't do anything to it. And you should already be saying, wait, I already know that coordinate. That's on my unit circle already. I already know where that's located. And so sure enough, we find that root 3 over 2 is when, again, cosine of the angle equals root 3 over 2. When does that occur? Pi over 6. And therefore my angle is pi over 6. All right. Now, knowing all of that. So, and that seems easy enough, right? Find the radius, divide by that radius to find that angle. Well, what about if they give me the radius and they give me the angle? I think this is even easier still. Because now what you're going to do, your steps look a little different, because I have the angle and I know what the coordinates are on the unit circle. Okay, so step one is to use the angle to determine the coordinates on the unit circle. And then, we'll do that in a second. So pi over 4. Oh, that's root 2 over 2 and root 2 over 2. Fabulous. And then what you're going to do, step 2, is you're going to scale it up using the radius. So what I'm going to do is I'm going to multiply these by 3. So this is 3 root 2 over 2, comma 3 root 2 over 2. Let's try another one. Pi over 6. Okay, well, the coordinates of pi over 6 are root 3 over 2, comma 1/2. And then I'm going to scale it using 1. And so that means I'm going to multiply everything by 1, and I get root 3 over 2, comma 1/2. And so the rectangular coordinates would be root 3 over 2, comma 1/2. You might ask, will there be negatives and all that stuff? Yes, but not today. We'll work with just the first quadrant for now until we can get quite comfortable, and then we'll move into that. All right, and so that's how you deal with polar coordinates.